2.6, getting information from a model. So there's a couple different ways you can go about getting information from a model. The first of which is graphically. If you have the model and you can graph it with your calculator, then you can just use the built-in functions trace or table in order to answer questions that you have about the graph. Algebraically, you actually solve the equation to determine values that you're looking for. So let's look at an example. When is y equals 5x plus 3 equal to 48? Okay, so you could graph it. You can graph y equals 5x plus 3, and you can graph y equals 48 on the same axes, and then take a look at what the intersection is, right? We talked about this in class, how to find the intersection of two curves on your calculator. So you go and calculate the intersection, and it would just pop out the numbers for you, x equals 9, y equals 48 for the point. Now, algebraically, if you were to solve this, you're going to set these two things equal to each other, right? So 5x plus 3 is equal to 48, and then solve for x. Subtract 3 from both sides. That results in a 5x equals 45. Divide both sides by 5, getting you the same x equals 9 that your calculator just gave you. The next piece is constructing models. And in constructing a model, what you need to do is first choose your variable. What is this equation about? That will be your x. Then translate the words into algebra, which means you have to then express things in terms of x or in constants if they're given as constants, and then set up the model, which means defining the equation that is that equation of x. Once you have a model, which we're going to talk about specific models from the book in terms of how to work with those. The first one being interest, the second one is mixing and concentration, and the third being geometric models, like we did earlier. So with an interest model, we have the equation I is equal to PRT that we will be working with. I in this case is your interest. P is your principal balance, R is the rate of that interest as it's applied, and T is in time, usually years for the purposes of this particular model. An example would be, say, if Joey takes out a loan of $8,000 at a 3% interest and he pays it off after 2 years, how much interest does he pay? So, right, we need to recognize, what are we trying to find? Well, we're trying to find the interest, so that's I. That is the variable in this case that we have to solve for. What we are trying to find? I, interest. P is the principal balance, and the principal balance is the amount that he took out for the loan, which is the $8,000. The rate of that interest, that 3% rate of interest, is 3%, which will convert to a decimal, 0.03 in the actual equation. And then the time, well, he paid it off after 2 years, so time is in years, 2 years. Then we just substitute these values into our equation. So I is equal to P times R times T, and P was 8,000, R was 0.03, and T was 2. So 8,000 times 0.03 times 2 gets us $480 in interest that he paid for 2 years of 3% interest on this $8,000 loan. Now, if we try to go the other way, if he only spent $300 in interest, how long did it take him to pay it off? So now you know I. So I is 300. T is exactly what it's asking. How long? How long did it take him to pay it off? So T is what we're trying to find. And then P and R are the same. It's the same problem, just consider this case instead. Now, if that's true, we set up our equation I equals PRT. So 300 was I, equal to P, still 8,000, R, still 0.03, and then T is what we're trying to find. So T we just keep as T. And then you just would solve that equation. So simplify the 8,000 times 0.03, that puts it at 240T. So 300 equals 240T. Divide both sides by 240, getting you 5/4 is equal to the time. So 5/4 years, or a year and a quarter of a year is about 3 months. So you could consider that in terms of our normal experience of years, 1 year and 3 months. The next type of problem is mixing and concentration, and mixing and concentration is usually more challenging. So the idea is relatively straightforward because your concentration is based on the quantity of a substance in the mix that you have divided by the volume of the total mixture. So I'm going to try to use the example to highlight what you can from this problem. Okay, so we have a 2-gallon container of saline solution that has 1% salt. If it needs to be raised to 3% salt, how much salt needs to be added? So the thing we're trying to figure out is X, which is the salt that's added to this mixture in order to go from 1% to 3%. That's what we're trying to find. We know the initial volume was 2 gallons, so the total volume after adding the salt is going to be 2 gallons plus whatever volume of salt we add. Now, if the original concentration is 1% or 0.01, then with our original volume of 2 gallons, then the salt quantity is going to be that volume times the concentration. Right, I take the equation that we have up here, the C equals X over V, and I solve it for X by multiplying C by V. And C in this case is the 0.01, and the V is the 2 gallons. So the salt quantity that was the X for the original case is going to be 0.02, because 2 times 0.01 gets me 0.02. So if we add X salt to the 0.02 gallons of salt, then the total quantity of salt that I have in the mixture when it reaches 3% is going to be 0.02 plus X. Okay, so after I've added the salt, it's going to look like a concentration of 0.03 equal to the total amount of salt I have, which is that 0.02 plus X that we just had to work for to find, over the now total volume, which is the volume of the original solution plus the salt that was added. I'm not adding any more, like any water or anything else. I'm just adding salt to increase its concentration to plus X. Now I have the equation to solve. So now that I actually have the equation, I can solve it algebraically. Multiply both sides by the denominator, 2 plus X. That gets you 0.03 times 2 plus X equal to 0.02 plus X. Okay? Distribute the 0.03 to get us 0.06 plus 0.03X is equal to 0.02 plus X. Now I just need to get all my X's on one side and all of my constants on the other side. I'll start by subtracting the 0.02 from both sides to get me 0.04 plus 0.03X equal to X. Now I want to move those X's over. And so once I subtract the 0.03x from both sides, I'll have 0.04 is equal to 0.97x. Then it is merely divide by the 0.97, right, to solve for x. So that's, in terms of fractions, would be 4 over 97, or the 0.04 over 0.97 reduces to that. If you put it in your calculator, that's approximately 0.0412 gallons of salt to be added in order to raise the concentration from 1% to 3% in a 2-gallon solution. I do suspect that this is difficult, so please feel free to send me any questions that you do have, and we will spend time on this in class. Geometric models are probably a little more straightforward because they're a lot like what we already did for some models when we did the rectangles and the 3 sides of a fence and so forth. You're using the shapes of what is being asked for in order to define the model. So for area, volume, etc. So I'll give you an example with perimeter. If you need to build a fence enclosure for new chickens, right? Say you just got some chickens and you need to have an enclosure for them. The space that you have is rectangular, but 2 of the sides are longer than the other 2 sides. So if they're specifically 4 feet longer than the other 2 sides, you'll have to actually draw it out so you can see this, right? First, let's determine a model for the length of fence that will be needed to build the enclosure. So I draw out the rectangle, right? That's what this guy is here. and 2 of these sides are 4 feet longer than the other 2 sides. So I naturally am going to define one thing as x, either the shorter side or the longer side. Naturally, we tend to go with the shorter side being x because it's easier to add than it is to subtract in terms of simplifying for your computations. There's usually less errors that way. So for perimeter, I want to add all of my sides. So if I add all 4 of my sides, then I have x plus 4 plus x plus x plus 4. And if I simplify this down, I'll have 4x plus 8 as the model for the length of fence needed. Now, from that model, I can now ask a question like, what are the dimensions of the enclosed area if I use 40 feet of fencing total? So that means that f, right, that we defined in our model is going to be 40. And then, so 40 is equal to 4x plus 8. And then I just need to solve for what x is. Now, I subtract 8 from both sides. We get 32 is equal to 4x. We divide both sides by 4 to get 8 feet. Okay? That just gives me x, though. That's not the dimensions. That's just x. So I still have to go back to my picture and recognize that the dimensions are the lengths of the sides. And so, in this case, since it's a rectangle, I can say that it is 8 feet for the x value by 12 feet for the x plus 4 value. So 8 feet by 12 feet rectangular enclosure. Please let me know if you have any questions.